In today's class, we are going to talk about farm design and survey, that is SRE 451. And we are going to start our discussion by defining what is meant by scale and a representative fraction. The scale of a map is the ratio that represents the relationship between certain distance on the map and the actual distance on the ground. You know, it is possible to map out a location, no matter how big the location is. All we need to do is that we have to reduce the actual length of the actual length that we measured from that location. That is where scales comes in. You understand? For example, we can have a scale of 1:50,000. The meaning of this scale is that one unit measurement on the map represents 50,000 units of the same measurement on the ground. Do you understand? Oh, 50,000, not 50. 50,000. That is one unit measurement on the map. That is, anywhere we have one unit on our map can look like this, you know. Our map can look like this. You understand? But adventure, if from this point to this point, if it is from this point to this point is maybe 1 meter. You understand? And we have already put it down. We have already noted that on this map, one unit on this map, one unit measurement, maybe 1 meter. Let me put it, since we are measuring in meter. 1 meter on this map represents 50,000 meter on the ground. Do you understand? This scale is what? 1:50,000. You understand? Because a scale is defined as the ratio that represents the relationship between certain distance on the map, that is 1 meter on the map, and the actual length and the actual distance on the ground, that is 50,000 meter on the ground. So every map, when you look at every map, you are going to see something like this. That is, maybe they can say 2 meter represents so distance. You understand? So that is what is meant by scale. Scale tells us how we have reduced the actual length of our measurement on the ground compared to what we have on the scale. Do you understand? So now let us move to representative fraction. Representative fraction refers to the ratio between any given length on drawing and corresponding length on the ground. You see, scales and representative fraction are related, but representative fraction, let me represent it. Let me just say RF. Representative fraction is can be expressed mathematically as the length on the map, length on map. Please, it's important that you note this formula. We are going to use it. Length on map all over length on map all over length on ground. You understand? Length on map all over actual length. You can put it like that, okay? So now, that is the mathematical expression of representative fraction. Don't forget, representative fraction refers to the ratio between any given length on the drawing. On the drawing signifies on the map. You understand? Do you understand? So don't get confused, okay? On the drawing signify on the map. So any given length on the map and the corresponding length on the ground. You understand? So that is the mathematical expression. Now I want you to put down this question. What is the representative fraction of a line 200 meter long represented by 40 centimeter on plan? Now let us start by listing all the parameters that were given in the question. We are given that the line was 200 meter long on the ground. Do you understand? That is 200 meter long on the ground. 200 meter long on ground. And on the plan in that question signify on the map. Are you getting what I'm saying? So on the plan, that is on the map, it was represented as 40 centimeter. Have you seen now? 40 centimeter long on map. You can put on map or on the plan. Okay. Now we are told to calculate the representative fraction. Don't forget that the representative fraction is expressed mathematically as length on map all over length on the ground, abi. So now look, we are given that the length on the ground is in meter, but the length on the map is in centimeter. So we have to first what? Convert to centimeter. The reason why we have to convert to centimeter is because the length on the map is in centimeter. You understand? Representative fraction is equals to length on map, length on map all over the length on ground. You understand? So the length on map is in 200 meter. Now let us convert 200 meter to meter. The first step is that we want to convert 200 meter to 200 meter to centimeter rather. You understand? So now don't forget that 100 centimeter equals to what? 1 meter. Do you understand? I don't want to forget from your basic measurement. You know, 10 centimeter, 10 millimeter equals to what? 10 millimeter equals to what? 1 centimeter. 10 centimeter equals to what? 1 decimeter. 10 decimeter equals to what? 1 meter. So in that case, 10 times 10 is 100. So 100 centimeter is equals to what? 1 meter. Do you understand? So now, if 100 centimeter is equals to 1 meter, how many centimeter? Let us represent as x. X centimeter is equals to 200 meter. Now, in order to get the value of x, what do? We cross multiply, abi? So 100 multiplied by 200, that is 20,000. So I'm going to have 20,000 is equals to x, 1x. So that means that x is equals to 20,000 centimeter. So 200 meter is equals to 200 centimeter. Do you understand? So we have already convert we've converted this. We have converted 200 meter to centimeter. Please, I want you to take note. It is important that you understand this. From your unit measurement, you know that 100 centimeter is equals to what? 1 meter. Now, in order to convert 200 meter to centimeter, I represent the centimeter as x. So that is why I said let x centimeter equals to what? 200 meter. And then I cross multiply. X multiplied by 1 meter, that will be what? 1x or x. And 100 centimeter multiplied by 200 meter, that will be, or let me give you the solution. X meter is equals to what? If x multiplied by 1 meter, that is what? X meter. 100 centimeter multiplied by 200 meter, that will be what? 20,000 meter centimeter. You can see now. So now the next step is that I'm going to divide both sides by meter. You understand? So meter will cancel meter, and this meter also will cancel meter. You understand? So I'm only left with what? X and what? Centimeter. So that is why that's how I got 2 and x is equals to 2 and 20,000 centimeter. Do you understand? So that's it. Now let us proceed with our calculation. The representative fraction is the length on map. Now we have already converted our length on map, our length on ground to centimeter. Now we can proceed. The representative fraction is it? Oh, sorry. It is a representative fraction. RF. Let me put it here. RF is equals to length on the map. The length on map is what? The length on map is 40 centimeter. So I'm going to have 40 centimeter all over the length on ground. The length on ground is 20,000 centimeters. 20,000 centimeter. You understand? So the representative fraction is equals to 40 centimeter all over 20,000 centimeter. That is 1 all over 500. You understand? So the representative fraction is 1 over 500. So now you can see how I calculate this. So you can calculate the representative fraction of any scale. You understand? So the first step is that if they are not in the same unit, you have to convert the unit to the unit on the map or the unit on the plan. They are both the same. You have to convert it to the unit on the map. After that, you divide the length on the map all over the length on the ground. You understand? So that is how to calculate the representative fraction. Another important aspect that we are going to talk about in this course is chaining. You know, there are various types of chain that is used in farm design. One of the most important chains that is used in farm design is Gunter's chain. You understand? Gunter's chain is introduced by Edmund Gunter. Yeah, it is introduced by Edmond Gunter, and the length of one Gunter's chain is 66 feet. Please, I want you to take note of that. Put down. I want you to write down, okay? Write it down. One Gunter's chain is equals to 66 feet, and one link is equals to 0.66 feet. You understand? So now, in every Gunter's chain, there are 100 links. Do you understand? In every Gunter's chain, there are 100 links. You know, we have chain. This is the typical representation of a chain. A chain have various links. Look at this. Look, this is a chain. This is a typical example of a chain. But this place are links. Have you seen it? So now, in Gunter's chain, we have 100 links. Are you getting it? And the length of Gunter's chain in feet, the length of one Gunter's chain in feet is 66 feet. And one link will now be 66 divided by what? 100. That is what? 0.66 feet. So that is how they got the 0.66 as a length, as a single length of one link. Okay, let me ask you this question. If we have a chain like this, we have chain. Now, let's say we have a chain like this. Now, let me ask you, how many links does this chain has? Let's count. We have 1, 2, 3, 4, 5, 6. So this chain has 6 links. You understand? But you can see these are the links. You see now, these are the links. Now this chain has 6 links, but one Gunter's chain has 100 links. Do you understand? One Gunter's chain has 100 links. One Gunter's chain, you can put it down. One Gunter's chain has what? 100 links. So in order to get the measurement of each link, what do? You divide the total feet, the total length of the Gunter's chain by the numbers of links. That is how we got 0.66 feet. Now let us look at some work example on Gunter's chain. Now write this down. What is the representation of 20 chain and 8 link in feet? Okay, what is the representation of 20 chain and 8 link in feet? What is the representation of 20 Gunter's chain and with 8 links in feet? Now, how do you change that to feet? Let's start by writing the parameter that we are given. We are given that the numbers of chain, that is 20 chain. We have 20 chain. And how many link? The link is 8 chain and 8 link. Okay, now let's start. The first step is that we are going to convert the chain to feet. Are you getting it? You have to convert the chain, the 20 chain to feet. Now, we have been told that one Gunter's chain is what? 66 feet. One Gunter's chain is 66 feet. So, let me say one Gunter's chain is equal to what? 66 feet. Now, how many Gunter's chain will be equals to 20? How many feet will be equals to 20 Gunter's chain? So let us represent that. Let us represent it as an x. Let 20 Gunter's chain be equals to x. Now we are going to cross multiply like we did the other time. Now x will multiply 1. Is that not it? So I'm going to have x is equals to 20 will multiply 66. 20 multiplied by 66 feet. The reason why I don't put Gunter, x multiplied by 1 Gunter, that is what? X Gunter. And 20 Gunter multiplied by 66 feet, that is 20 Gunter multiplied by 66 feet. At the end of the day, we are going to cancel this out. You understand? So that is why I don't put Gunter, okay? So now let's proceed. X is equals to 20 multiplied by 66 feet. So if you punch your calculator, you are going to get 1,320 feet. So 20 Gunter's chain is what? 1,320 feet. So we have already converted the 20 chain. So therefore 20 Gunter's chain is equals to 1,320 feet. Now let us convert the 8 link to feet. You understand? Because in the question we have been given that we are told to change the representation to feet. Are you getting it? So now let us change 8 links also to feet. Since we have known that 1 link is equals to 0.66 feet, one link is equals to 0.66 feet. Now let us represent the feet which 8 link will be equals as y. So 8 link is equals to y. Do you understand? So now the next step is that we are going to cross multiply. You understand? So y is equals to y multiplied by 1 link. That will be also what? Y link. But I don't need to put the link, because at the end of the day we are going to cancel this out. This link is going to cancel this link. You understand? So y is equals to 0.66 multiplied by 8 link. If you punch your calculator, you are going to get 5.28 feet. So this is what? 8 multiplied by 0.66 feet. So y is equals to 5.28 feet. You understand? So now we have already converted both the 20 chain and the 8 link to feet. The next step is that we are going to add both of these together. You understand? 20 Gunter's chain. Don't forget, we are dealing with Gunter's chain. Okay, 20 Gunter's chain and 8 link is equals to what? 1,320 feet plus 5.28 feet. You understand? So if you add this together, you are going to get 1,325 feet. 1,325.28 feet. You understand? So that is how to calculate, that is how to represent any length in Gunter's chain. That is how to represent it in feet. Do you understand? So now, another chain we are going to talk about in this video is engineer chain. One engineer chain is equals to 100 feet. Now I want to put this down. One chain is equivalent to 100 feet. Do you understand? Now, one chain is equals to 100 feet. This means that one link is equals to 1 feet. Do you understand? So one engineer chain consists of 100 links. Do you understand? Now please, I want you to pay attention here. One engineer chain has 100 links, and we know that one chain is equals to 100 feet. So one link will be what? 100 divided by 100. Do you understand? That is how we got this 1 feet. Do you understand? That is, if one chain is equals to 100 feet, and one chain consists of what? 100 link. So one link will be equals to what? 100 all over 100. That is 100 feet all over 100 link. That will be what? 1 feet. You understand? That is how we got this 1 feet. Do you understand? So now let us proceed. Now let's have some work example on engineer chain as well. The distance measured in engineer chain is recorded as 20 chain and 47 link. Express this distance in feet. Okay, let's start by writing out the parameters that were given in the question. We are given that the distance is 20 chain and 47 links. Okay, now we are told to express this distance in feet. Now the first step is that you first have to convert this 20 chain to feet, then you proceed to convert the 47 links to feet. Now in order to convert this 20 chain to feet, don't forget that one engineer chain is what? 100 feet. So if one engineer chain is 100 feet, so one chain is equals to 100 feet. So 20 chain will be equals to x. So if you cross multiply 20 multiplied by 100, that is what? 2000. So x is equals to what? 2000 feet. So 20 chain is the 20 engineer chain is what? Is when it's expressed as feet, we have 2000 feet. Now let us convert the 47 links to feet. don't forget that 1 length is equals to what? 1 feet. So 47 length will be what? 47 feet. You understand? 1 length equals to 1 feet. So 47 length is equals to what? 47 feet. You understand? So now we have already converted both 20 chain and 47 links to feet. The next step is that we are going to add both. So 20 chain and 47 link is equals to now 2000 feet plus 47 feet. That is 2047 feet. So the 20 engineer chain and 47 links is expressed as what? 47 feet, 2047 feet. You understand like that? I want you to note that the distance measured using engineer chain is expressed in chains and feet. Are you getting it? Unless if the question specified that express this distance in feet only, like the one that we did earlier. Do you understand? So I want you to got that. Okay, now I put down this question. Express 40 chain and 50 links in chain and feet. Express 40 chain and 50 links in chains and feet. Okay, let's solve that question. They want us to express, this is the distance, 40 chain, 40 engineer chain and 50 link. They want us to express this distance in chain and feet. Now, please, I want you to pay attention. They want us to express in chain and feet, but we have been given that we have 40 chain, so there is no need of converting down to feet because they want the answers to be in chain and feet. The only thing that we have to do in this question is that we have to convert only the length to feet. Do you understand? So this will be 40 chain and now don't forget that 1 link is equals to what? 1 feet. Abi? So 50 link will be equals to what? 50 feet. Okay? So the distance, this distance is 40 chain and 50 feet. You understand? Because this question specified that they want the answers to be, they want the distance to be in chain and feet. Okay, now what if you are now asked to express the distance only in feet only? You understand? You can see that the second question specified that they want the distance to be in feet only. Therefore, we have to convert both. We have to convert both chain and the link. You understand? You are still dealing with this question, okay? So now the second question, they want the answers to be in feet only. Now don't forget that 1 engineer chain is equals to what? 100 feet. Abi? So if 1 engineer chain is equals to 100 feet, let 40 engineer chain is equals to what? X. So we are going to cross multiply. Abi? So now x multiplied by 1, that is x. 100 multiplied by 40, that is 4,000. So 40 chain is equals to what? 4,000 feet. Now the total distance will be which is what? 40 chain and 50 link is equals to, that is 4,000 feet. 4,000 feet plus we have already converted 50 links to feet, so plus 50 feet. Do you understand? So that will be 4,050 feet. You understand? So we have already converted the engineer chain to what? To feet only. You understand? So now that is how to convert distance measured in engineer chain and distance measured in Gunter chains to feet. You understand? So now another concept that I want us to talk about in this course is the concept of azimuth and bearing. What do we understand by azimuth? Azimuth refers to the clockwise horizontal angle from north direction. I want to write that. Azimuth refers to clockwise horizontal angle from north direction. Okay? Now let's say we have this cardinal point. We have this cardinal point. Please, I want you to pay attention here. Okay? This is north, Abi. This is south. This is west, and this is east. Do you understand? Okay, this is the 4 cardinal points. azimuth is measured from the north direction. And the major difference between azimuth and bearing is that azimuth is greater than 90 degrees, but bearing is not greater than 90 degrees. You are going to see as we progress. Okay, now let's say we have that 4 cardinal points, and we have a straight line. We have another bisector here, and I have another bisector here. Please, I want you to follow this carefully, okay? Let's say this angle here is 40 degrees, okay? And the angle around this place is 65 degrees. The angle here is maybe 56 degrees. 56 degrees. And the angle here 74 degrees. Okay, now let me name this angle A and AB. Let me say this line ABCD. We have line A and C, and we have line D and B. Okay, now we want to measure the azimuth of this line, and we also want to measure the bearing of the line. Okay, now let's start with line. Let's say this point is point 0. Okay, please, I've not done anything. Okay, this is the question. Now, Abby, this is the question. I've not done anything. I've not measured the azimuth, neither have I done the bearing. Okay, this is the question. Let's say they gave us this question and said that we should measure the azimuth of line OA. I discovered that you cannot see the diagram that I drew here, so I shift the diagram to the right hand side so that you can see it. Okay, I've not done anything. Okay, so now let's say this point is point 0. Okay, now we are told to find the azimuth of line OA. Find the azimuth of line OA, don't forget that this line OA, line OB, this one, let me call this one, line OB, line OC, and line line OD. We want to find the azimuth of this line. Now let's start with the azimuth of line OA. Don't forget that I told you azimuth refers to the clockwise horizontal angle from the north direction, and is usually greater than 90 degrees. So now the azimuth of line OA will be the angles that lies between the north line and the line OA. You understand? The azimuth of line OA is the angles that lie between this line, which is the line towards the north, and the line that we are dealing with. In this case, that is line OA. So the azimuth of line OA is what? This angle. Do you understand? And the angle is what? 40 degrees. Please, do you understand? I want you to understand, please. The azimuth is the angle that ranges from this north line to the line that we are dealing with. You understand? Now we are dealing with line OA. Now the angles that lies between this line, that is what is called the azimuth of line OA. Do you understand? So the azimuth of line OA is what? 040 degrees. Do you understand? Now let us proceed to line OB. Line OB is, this is line OB. Line OB. This is this line. Don't forget that I told you that the azimuth of a line is the angle between this north line and the line itself. Are you getting it? The angle between this line and the line itself, that is what we call the azimuth of a line. Now let us find the azimuth of line OB. The azimuth of line OB will be the angles that lies across this region. Are you getting it? That is the azimuth of line OB. Now let us find the angle. Don't forget that this angle, let me clean this because we are done with line OA. We are dealing with line OB now, okay? Don't forget that this angle, this angle is what? This angle is what? 90 degrees. Do you understand? This north, if you have something like this, don't forget that this is like north east. So this angle is what? 90 degrees. Abi? So this angle is 90 degrees. But I don't know the value of this angle. In order to calculate the azimuth of line OA, I have to add 90 degrees plus this angle. But I don't know the value of this angle. How do we calculate the value of that angle? Since I know that this angle here also is what? 90 degrees. Don't forget that. How will I draw this thing? Okay, let me just draw it here. Please, I want to pay attention. If I have something like this, a typical example of right angle. southeast. The sum of this angle is what? 90 degree. So the sum of this angle also is what? 90 degree. But I know this angle as 68 degree. Now how do I calculate the value of x? I have to subtract 90 degree. I have to subtract 68 degree from 90 degree. Do you understand? Please, I want you to understand. The total angle here is what? 90 degree, which is also the same thing as what? This angle. Because I have east and I have south. East and south. This is the right arm. This is a right angle. Are you getting what I'm saying? So now, the sum of this angle here is 90 degree. But I know a part as what? 68 degree. In order to calculate this x, I have to subtract what? 68 degree from 90 degree. So the value of this angle, which is x, x will be equal to what? 90 degree minus 68 degree. So 90 degree minus 68 degree, that is 22 degree. You understand? So the value of x here is what? 22 degree. Do you understand? So we have gotten this angle. So in order to find the azimuth of line OB, don't forget that the azimuth of line OB is the angle that ranges from the north direction, from the north line towards to where line OB is, and line OB is here. So the sum of the angle here is 90 degree. The total angle here is 90 degree. So in order to get the azimuth, I'm going to add 90 degree, which is the sum of angle in this place, plus this 22 degree. Do you understand? Because the sum of angle here is 90 degree, and line OA, line OB has already passed this side. Immediately it got to this point. The sum of angle here is what? 90 degree. So it got to this point. The sum of angle from this point to this point is what? 22 degree. So in order to get the total angle that in between this north line and line OB, which is the azimuth of line OB, that will be what? 90 degree plus what? 22 degree. So the azimuth of line OB is what? 90 degree plus 22 degree. If you add 90 degree plus 22 degree, that is 112 degree. So the azimuth of line OB is what? 112 degree. Please, do you understand? There is no magic to this thing. You understand? Just get the concept, okay? So let us proceed to calculate the azimuth of line OC. Let me erase this. Let me erase this also. Let me erase this also, okay? Now let us calculate the azimuth of line OC. Don't forget that the azimuth of a line is the angle that lies between the north line and the line itself. Are you getting what I'm saying? That is the azimuth. That is the basic concept. That is the basic concept behind what you are doing. Now, this is line OC. This is line OC. The angles that lie between this north line and line OC, that is the azimuth of line OC. So I will calculate the angle that lies from here to line OC. You understand? So that is the azimuth of line OC. Now, to get the azimuth of line OC, I have known that from this place, this angle here to this angle here is what? 90 degree. Hope you know that. And this angle here to this angle here is what? 90 degree also. 90 degree. This angle here to this angle here is 90 degree. Just like if I have something like this. If I have something like this, you understand? So this angle here to this angle to this angle is 90, and this from here to here is what? 90 degree. Now, don't forget that this is where this is where we are calculating this angle to this point. Now we have gotten this angle and this angle. Now we have to add 56 degree. Do you understand the reason why we are adding 56 degree? Because line OC, the azimuth of line OC ranges from this north pole to what? To this point. But we have already known this angle as 90 and this angle as 90. So in order to get the azimuth of line OC, I have to add 56 degree. So for this, I'm going to have 90 degree plus 90 degree plus 56 degree. So in order, if you punch your calculator, you are going to get 236 degree. That is the azimuth of line 236 degree. That is the azimuth of line OC. Do you understand? Now let us calculate the azimuth of line OD. Please, I want you to pay attention. It is very, very simple, okay? Don't get confused. When you talk about azimuth is the clockwise horizontal direction measured from the north pole. Just put it like that. Now, if azimuth is the clockwise horizontal direction measured from the north pole, in which direction does a clock move? A clock move like this, Abi. So now, the azimuth of any line is the angle that lies between the north pole and that line. You understand? So the angles that lie between this north pole and this line OC is what? 90 degree plus 90 degree plus this 56 degree. That is circling. Now let us calculate the azimuth of line OD. Don't forget that this is line OD, and we are measuring the angle in the clockwise direction. Do you understand? So now the clockwise, that if you want to calculate the azimuth of line OC, it will be the angle between this place, ranging from here, ranging to this place. Do you understand? That is the azimuth of, azimuth of line OD, not OC now. That is the azimuth of line OD. Now, I have known that from this point to this point is what? 90 degree, abi? From this point to this point is what? Also 90 degree. From this point to this point is also what? 90 degree. But I need to get this angle before I can calculate the azimuth of line OD. In order to get this angle, what will I do? Yeah, I'm going to subtract 90 degree. I'm going to subtract 74 degree from y, because the sum of this angle is what? 90. Just like if I have something like this. This is west, and this is what? North. This is 90 degree. This is angle 90 degree. You understand? In your basic mathematics, just remember, okay? Now, this angle is what? 90 degree. In order to get the value of y, I'm going to, don't forget that y plus 74 degree is equal to what? 90 degree. So in order to get the value of y, that is y is equal to 90 degree minus 74 degree. If you subtract 90 degree from 74, that is 16 degrees. So the value of y is what? 16. Equals to 16 degree. So the value of y here is what? 16 degree. If you add 74 degree plus 16 degree, you are going to get 90. Are you getting it? So now, in order to calculate the azimuth of line OD, that will be this angle to this angle, that is 90. So I'm going to have 90 degree plus this angle to this angle, that is what? 90 plus 90 degree plus this angle to this angle plus 90 degree plus 16 degree, because this is where line OC stop. I don't need 74 degree. Do you understand? This is where line OC stop, and I told you that azimuth is the clockwise horizontal direction clockwise angle measured from the north pole. Are you getting what I'm saying? So, and when I measure this angle from here, it passed through here and it got to where line OD is. That is 90 degree plus 90 degree plus 90 degree plus 16 degree. So if you add this together, let's add this. That is 270 degree plus 16 degree. So the azimuth of line OD, is 286 degree. 286 degree. So that is the azimuth. That is all we have to know about azimuth. Have you seen that? It's very, very simple. Now let's talk about bearing. Let's say we have this diagram and we are told to calculate the bearing of line OA, bearing of line OA, bearing of line OB, bearing of line OC, and bearing of line OD. Don't forget that O is the center. Are you getting it? O, this is O. Okay. Now let us proceed. To calculate the bearing of line OA, let me start by defining what it means by bearing. Bearing is also similar to azimuth, but bearing is not greater than 90 degrees. You understand? And bearing of a line is the angle which the line makes with the meridian. You understand? That is the simple definition. You understand? That is the simple definition. Bearing is the angle which a line makes with the meridian. The meridian are the 4 cardinal points. You understand? So now, the bearing of line OA is what? The bearing of line OA is this angle, because this is the angle which line OA makes with this meridian. You understand? So that is not 40 degree south, not 40 degree east. So I'm going to have it like this. Do you understand? Now let's find the bearing of line OB. You understand? In order to calculate the bearing of line OB, don't forget that this line OB has passed the first quadrant. Are you getting it? Line OB has passed the first quadrant. Do you understand? Line OB, this is the first quadrant. This is the first quadrant. Line OB has passed the first quadrant. So the meridian that we are going to take into consideration is what? The meridian of west and east. You understand? And the angle which line OB makes with the meridian is this angle. Do you understand? Please, I want you to understand, okay? The angle which line OB makes with the meridian is this angle. So now, in order to calculate this angle, how do we go about this? Don't forget that the sum of angle here is what? 90 degree. So in order to get the value of x plus 50 degree is equals to what? 90 degree. In order to get the value of x is equals to what? 90 degree minus 50 degree. That is what? 40 degree. So the value of x is what? 40 degree. The value of angle here is 40 degree. So I have gotten the angle which line OB makes with the meridian north and west east. So the angle which line OB makes with this meridian is what? 40 degree. So the bearing of OB is what? That will be southeast. You understand? Southeast, south 40 degree east. So I'm going to have south 40 degree east. Please, do you understand? It's very, very important that you understand this basic concept. The bearing is the angle which, the bearing of a line is the angle which the line makes with the meridian. That's it. And the meridian, I told you, are the 4 cardinal points that we have here. Now, the bearing of line OB is the angle which line OB makes with this meridian. This is the meridian. This is meridian, okay? This is the meridian. The angle which line OB makes with the meridian is what? 40 degree. So because the angle is resting, we measure bearing also in clockwise direction. You understand? So the angle which line OB makes with the meridian is what? 40 degree. Because when we measure bearing in also clockwise direction, we measure it in clockwise direction. The angle between here and here is what? 40 degree. The angle between here and here is what? 40 degree. Do you understand? Okay, now let us proceed. Now let us take the bearing of line OC. Maybe in order to help you understand this, let me draft out the side which line OC falls to. This is the west and this is what? The south, okay? And we have the angle OC. This is O and this is C. Don't forget that bearing is measured in what? In the clockwise direction. So this angle here is the angle that we are talking about. You understand? Because we are measuring bearing in the clockwise direction. You understand? So this angle here is the angle which OC makes with the meridian. Please, do you understand? Thank you. Now let's proceed. So what is the, if you compare this angle with this angle, you can see that line OC makes 55 degree with the meridian. You understand? So the bearing of line OC will be what? South 55 degree west. You understand? Because we are proceeding towards the west. You understand? Though the angle, the bearing of line OC makes an angle of 55 degree with the meridian from this with this meridian, which is the south meridian. You understand? So, but we are progressing towards the west, so we must put this south 55 degree west. You understand? So now this is 55 degree. Now let us deal with the last one, which is the bearing of line OD. Don't forget that this is OD. Let me draft it out again. Let me draft the diagram so that you can understand. I want to just make sure that you understand this, please. Okay, now don't forget that this is line D, okay? This is line O, okay? And we know that bearing is measured in the clockwise direction. You understand? So the angle will start from here and end in here, because bearing cannot be greater than 90 degree. Bearing is not greater than 90 degree. Now the angle here is the angle that line OD makes with the meridian. Now how do we calculate this angle? From this, we have been given that this angle is what? 45 degree. You understand? This angle is 45 degree. Let me put it north and what? What's the next one? North and west. Abi? North and west. Okay. We have been given that this angle is 45 degree. Now this angle is x. In order to get the value of x, don't forget that the sum of this angle is what? 90 degree, Abi. So x can be 90 degree minus 45 degree. That is what? 45 degree. So the angle here is what? North 45 degree west, northwest. Yeah, we have determined the bearing of this. Now we can also determine the azimuth. The azimuth of this line. Let us start with line OA. What is the azimuth of line OA? The azimuth of line OA is what? 40 degree. That is 40 degree, because azimuth is the angles that ranges from the north to the line that we are dealing with, and we are dealing with line OA now. So the azimuth is 40 degree. Now what is the azimuth of line OB? Line OB. What is the azimuth? The azimuth of line OB, let me change the marker here. The azimuth of line OB will be the angle that ranges from the north pole to the line that we are dealing with. Okay, the azimuth will be the angle from this place to this place. But I know that the angle from here to here is what? 90 degree. Abi? So I need the angle here. How do I get the angle here? Subtract 90 degree from 50 degree. Subtract 50 degree from 90 degree. That is what? 40 degree. So the azimuth of line OB, is what? 90 degree plus 40 degree. Do you understand how I got that? So the azimuth is 130 degree. 130 degree. Now I want you to determine the azimuth of line OC and line OD. Okay? I want you to determine that azimuth. Okay? That will be just a test. If you get it correctly, this is the answer. But I want you to try it before you check this answer. Okay? The azimuth of line OC is what? 90 degree plus 90 degree plus 55 degree. Add this together, you're going to get the azimuth. Now, the azimuth of line OD, please, I want you to try the question and mark yourself. That's the reason why I'm giving you this, okay? I want you to try this question. Don't check this answer before you pause the video. Try the question before you check this answer. Now, the azimuth of line OD is 90 degree plus 90 degree plus 90 degree plus the angle here. You understand? 90 degree plus 90 degree plus 90 degree plus the angle here. How do I get the angle here? Subtract 90 degree from 45 degree. Subtract 90 degree from 45 degree. That is, then x will be what? 45 degree. So the azimuth of line OD, is what? 90 degree plus 90 degree plus 90 degree plus 45 degree. Okay? Because azimuth is the clockwise horizontal angle measured from the north pole to the line that we are dealing with. You understand? So that is the answers. Okay, now another concept that I want us to talk about in this course is the concept of fore bearing and back bearing. Now under this, I want us to note 4 points. Okay, the first point that I want you to note is that every line has 2 bearing. Okay, every line has 2 bearing. So if I draw a line like this line that you see here has 2 bearing. Okay, now that's the first point. The second point is that the bearing of a line in the direction of the survey is known as fore bearing. Now what is fore bearing? Fore bearing is the bearing of a line in the direction of the survey. You can see that. So the bearing of a line is the direction of the surface. In the direction of the survey is known as the fore bearing. Okay. Now the third point is that the bearing of a line opposite to the direction of the survey is known as the back bearing. That is, if the survey progresses northward, peradventure if the survey progresses north-south, the bearing of that line is the angle between the line that we have. Okay, that is what it means by fore bearing. The bearing of a line in the direction of the survey is known as the fore bearing, and the bearing of a line opposite to the direction of the survey is known as the back bearing. Now the next point is that the fore bearing and the back bearing of a line differs. Please, I want you to note that those points. Then point 5 is that the back bearing of a line can be calculated from its fore bearing. Okay, now let's look at the application of what we have learned so far. Let me start by with the last statement. The back bearing of a line can be calculated from its fore bearing. Now look at this formula. It's very, very important that you know this formula. The back bearing, let me represent it as dB. Back bearing is equals to fore bearing plus 180 degree. This is one of the formula that we use in calculating back bearing from fore bearing. This formula is used if the fore bearing is less than 180 degree. That is, if the fore bearing is less than 180 degree. You understand? Now, to determine the back bearing of a line which its fore bearing is greater than 180 degree, we use this formula: fore bearing minus 180 degree. You understand? That is, if the fore bearing is greater than 180 degree. So I want you to master this formula because we are going to use it to solve question. Okay, now this is the first question. There are 2 ways to determine back bearing. The first one is what I just discussed now, okay? That is the formula method. However, you can also calculate the Fore bearing without even making use of formula using the diagram method. I'm going to teach you both methods. Now you're going to choose the one that you understand, okay? Now let's deal with the formula method, which is this. Find the back bearing of the following lines. We have line, okay? We have line AB. The Fore bearing is what? 41 degree, 15 minutes. 41 degree, 15 minutes. I'm going to teach you how to press this on your calculator, okay? 41 degree, 15 minutes. The bearing of line BC is the Fore bearing. All these are Fore bearing, you understand? We want to determine the back bearing of this line from its Fore bearing, you understand? So the angles that you are given are Fore bearing. Are you getting what I'm saying? So now let's start. For line BC, we have 138 degree and 18 minutes. Line CD. All these lines are different, so they are not, they are not the same. We are only given the Fore bearing. Now we have to calculate the back bearing separately. You understand? Don't say because this is AB, this is BC. No, they are not the same. Okay, we are dealing with different questions entirely. Each of them are different. Okay, so now line CD is 208 degree, 22 minutes. Okay, and line DE is the Fore bearing of line DE is 316 degree, 26 minutes. Oh, sorry, 26 minutes. Now, let me first teach you how to punch this on your calculator. Now, take your calculator and look at this place. This is my calculator. You can see. This is my calculator. You can see I've already on it. Now, let's say I want to punch. The Fore bearing of line AB, which is what? 41 degree, 15 minutes. Now look at this calculator. I'm going to punch 41. That is 40. You can see 41. Now look at this sign on your calculator. Watch this sign on your calculator. This is the sign. You have seen degree, 41 degree. Then you proceed to press 15. That is what? 15. You can see 15. Then you press that sign again. That on this calculator you have seen 41 degree, 15 minutes. You can see now. So that is how to punch that on your calculator, because it's very, very important that you know that. Now let's proceed. Let's start with line AB. Okay, let's start with line AB. Now the first step is that you are going to draw your 4 cardinal points. Okay, this is my 4 cardinal points. I don't know where the angle will fall to. Are you getting it? But the Fore bearing is what? The Fore bearing of, I will call this point A, because we are dealing with line. Line has a starting point and an ending point. Are you guys what I'm saying? It starts from somewhere and end from somewhere. So this line starts from A. Are you guys what I'm saying? So the Fore bearing is what? 41 degree and 15 minutes, Abby. So now I want to ask you, is 41 degree and 15 minutes in the first quadrant or the second quadrant? Which quadrant is 41 degree and 15 minutes? Yeah, 41 degree and 15 minutes is in the first quadrant, and this is the first quadrant, Abby. This is the first quadrant on our cardinal point. So 41 degree will be here. Don't forget that the total angle here is what? The total angle from this place is what? 90 degree. But the angle that they gave me is not up to 90 degrees. So 41 degree, 15 minutes should be here. Should be around this place, okay? So that is the angle that I'm going to measure. 41 degree. So let me just rule a line. So the Fore bearing is what? 41 degree, 15 minutes. Please, do you understand? Assuming that the angle is 130 something degree, that means it has passed the first quadrant, which is here. It has moved to the second quadrant, you understand? But the angle is still in the first quadrant. So 41 degree and 15 minutes will be in the first quadrant. Now this is line A. This is point A. Another point is point B. You understand? Because I told you that a line has a starting point and an ending point. It starts from somewhere, just like if I have something like this is a line, Abby. So it starts from here and ends from here. So when we are talking about line starts from A and it ends at B, Abby. So the Fore bearing is what? 41 degrees and 15 minutes. Now we are told to calculate the back bearing. Oh, sorry, I'm already dealing with the diagram method. We can actually make use of this formula to simply determine this the back bearing of this line. Now let's first use the formula method, okay, before we proceed to the diagram. I'm already using the diagram method, okay. Now look at this. Let us first determine the back bearing of line AB using the formula method. Don't forget that the Fore bearing is what? 41 degrees and 15 minutes. Now I want to ask you, is 41 degrees and 15 minutes greater than 180 degrees or less than 180 degrees? Yeah, 41 degrees and 15 minutes is less than 180 degrees. Now you are going to go back to your back bearing formula. In which case are we going to use? This is the Fore bearing. The Fore bearing is less than 180 degrees. So we are going to make use of this formula, you understand? Because 41 degrees and 15 minutes is less than 180 degrees. So we are going to make use of this formula. So the back bearing of this line, the back bearing of line AB, is what? That is the Fore bearing, which is what? 41 degrees, 51 minutes plus 180 degrees. That is what? Plus 180 degrees. So the back bearing of this line is, okay, let me teach you how to punch that. Look at this calculator. We want to punch 41 degrees and 15 minutes plus 180 degrees. So just press 41 degree, 15. Don't put any space, so don't put any sign. 15 minutes plus, you can see, plus 180 degree. 180. You can see, just press 180. You have to put degree, okay? And the sign for degree is here. This is the sign for degree. You can see the button I'm pressing. You can see this is the sign for degree. Look at the button that I'm pressing. This is the sign. This is the sign for degree. Look, this is the sign for degree, okay? Now press it. You can see that you have seen degree on the top of that 180 degrees. So now you have to, if you press equals to, you're going to get an accurate answer. You have seen you have 221 degrees and 15 minutes. So that is how to punch that on your calculator. Now you add that together, you're going to get 221 degrees and 15 minutes. You understand? So we have calculated the Fore bearing of line AB. The formula method is actually simple. You understand? So you can just check whether the Fore bearing is greater than or less than 180 degrees, then apply your formula. Now let's deal with the Fore bearing and the back bearing of line BC. The back bearing of line BC. This is the back bearing of line AC. The back bearing of line BC is what? Now 138 degrees and 18 minutes is also less than 180 degrees. So I'm going to use this formula, which is Fore bearing plus 180 degrees. Now we're going to add 138 degrees and 18 minutes plus 180 degrees. That will give us 138 degrees, 18 minutes plus 180 degrees. That is 318 degrees. 318 degrees and 18 minutes. Okay, so do you understand? Now let us calculate the back bearing of line CD. Now look at this. The Fore bearing of line CD is what? 208 degrees 22 minutes. Now I want to ask you, is 208 degrees and 22 minutes less than or greater than 180 degrees? Yeah, it is greater than 180 degrees. So we cannot use this formula. We proceed to use the second formula. So the Fore bearing minus 180 degrees, that is 208 degrees minus, this is for 1, let me just name this 1, 2, 3, 4. Okay, so this is for 1, this is for 2, this is for 3. So the back bearing of the third, which is line CD, that is 208 degrees, 21 minutes minus 22, sorry, this is 22, okay, 22 minutes minus 180 degree. Please, I want you to note something, that your formula, your Fore bearing will determine the type of formula that you are going to use. If the Fore bearing is greater than 180 degree, as this case, you are going to make use of what? FB, Fore bearing minus 180 degree. So, proceed here. If you punch your calculator, you are going to get 28 degree, 22 minutes. You understand? 28 degree, 22 minutes. Now, let us proceed to the third one, which is for the back bearing of line DE. Oh, let me just put it here. Or let me just clean this B, okay? For the back bearing of line, the third one. Now, 316 degree and 26 minutes is what? Is greater than 180 degree. So, we are going to use the second formula. That is 316 degree, 26 minutes minus 180 degree. So, if you punch your calculator, you are going to get 136 degree, 26 minutes. Do you understand? So that is how to determine the back bearing of from a Fore bearing using the formula method. Now, let me teach you the second method, which is the diagram method. Which is, I'm already progressing with that method. Before I realize that, I have to first teach you the formula method. Okay, now let's check whether what we got here is correct. Now we have the first question, which is what we have been given, that the Fore bearing is what? 41 degree and 15 minutes, which is what I've already done here. I've already started the diagram. That is, then this place will be what? Point B. Please, I want you to pay attention in this place. The back bearing of this angle is this. Are you getting it? Don't forget that this is the Fore bearing that we are given in the question. The back bearing is the angle that ranges from the North Pole to this line. Are you getting it? So now let us proceed. In order to calculate this angle, don't forget that from this side to this side is what? 90 degree. And from this side to this side is what? 90 degree. So the total angle from this point to this point is what? 180 degree, which is what? 90 degree plus 90 degree. That is what? 180 degree. Now I need to get this small angle. I need to get this angle. Please, do you understand? I need to get this small angle so that I can calculate the back bearing of this angle. Now let us proceed. In order to calculate the value of this angle, there is something called alternate angle. Are you getting what I'm saying? From your basic trigonometry, alternate angle are what? Equal. Are you getting it? So, it's not trigonometry. Don't forget, from your basic mathematics, alternate angle are equal. And this 41 degree 15 minutes is alternate to angle X. Are you getting it? So therefore, angle X is what? 41 degree 15 minutes. Angle X is also 41 degree 15 minutes because alternate angles are equal. This angle is alternate to this angle. Are you getting it? And this angle is also what? Alternate to this angle. Do you understand? So, but I don't need this angle. I only need this small angle so that I can add it to 180 degree in order to get the back bearing of what? Angle 41 degree 15 minutes. So the back bearing now will be what? 180 degree plus angle X. And angle X is what? 41 degree 15 minutes. So 180 degree plus 41 degree 15 minutes. That is 288 degree 45 minutes. I think something is wrong. Let me press it. 180 degree plus 41 degree 15 minutes. That is 221 degree 15 minutes. So have you seen that we got the same answer when we make use of the diagram method and the formula method? Now let us proceed. You can try the second method. You can try the second question by yourself. You can just use the approach that I use to calculate the back bearing of that. Now let us try the third one. Okay, let's try the third one. Let's calculate the back bearing of 208 degree and 22 minutes using the diagram method. Let's say this is point C. Okay, so the bearing of the Fore bearing of point C is 208 degree. So, and 208 degree falls in the third quadrant. So the angle is going to come like this, because from this place to this place is 90, 180. From this place to this place, that is 270, but it's not up to 270, so it will lies across this region. You understand? So the line is going to be drawn from this point. Have you seen it? Do you understand? Because the angles is 208 degree 22 minutes. It's not up to 270. You understand what I'm saying? So the angle is going to lie across this place. So let's proceed. Now, this is point C and this is point D. Do you understand? Now, to calculate the Fore bearing of, to calculate the back bearing of point C, don't forget that this angle is what? 208 degree 22 minutes. Now, to calculate the back bearing of 208 degree 22 minutes, the back bearing of 208 degree 22 minutes will be from this place to this place. You understand? How do I know that? Don't forget that we measure bearing from the northward. Abi, we measure bearing from the northward. Do you understand? So, and the bearing of a line is the region that it covers from the north pole to that line. The region that this bearing covers from the north pole is this place, or it touches this line. Do you understand? So that is how I got it. That's how I got the back bearing. The back bearing is this small angle. So now let us proceed. Let us represent these angles as x. Do you understand? Now, I told you that alternate angles are equal. Are you getting it? Angles that look like this. Maybe this is the example of alternate angle. An angle that look like this. These angles and this angle are equal. Are you getting it? Please, do you understand? And if I have something like this, these angles and this angle are also what? Equal. Maybe I have something like this. This angle and this angle are what? They are also equal. Those are alternate angles. And if you look at this angle. I have something like this. Are you getting it? So this angle is equals to this angle. This place is also equal to x. Do you understand? Now, to get the value of x, don't forget that from this point to this point is what? 208 degree 22 minutes. To get the value of x, don't recall that from this point to this point is what? 180 degree. This is 180. That is, from this point, look at where my hand is. From this point to this point, that is what? 180 degree. And from this point to this point is what? 208 degree 22 minutes. Now, in order to get this angle, what will I do? I'm going to subtract 208 degree 22 minutes from 180 degree. And that's what I'm going to do now. 208 degree 22 minutes minus 180 degree. That is, the value of this angle x is what? 28 degree 22 minutes. Do you understand? Because from the angle here, from this point, from the north pole to this point is what? 180 degree. But they have already given me that from this point to this point is what? 208 degree 22 minutes. So in order to get this small angle, I'm going to subtract this angle from this angle. That is 208 degree minus 208 degree 22 minutes minus 28 degree 22. Sorry, 208 degree 22 minutes minus 180. That is how I got the value of x, which is this small angle, as 28 degree 22 minutes. And I told you that alternate angles are what? Equal. So the value of x here is also the same thing as what? The value of x here. Therefore, the angle here will be what? 28 degree 22 minutes. Do you understand? Therefore, the back bearing of 208 degree 22 minutes is 28 degree 22 minutes. Now, another concept that I want us to talk about in this course is how to find the angle between two lines. It is possible to find the angle between two lines. Let's say we are told to find the angle between the line OM and ON. Find the angle between the line OM, which is 24 degree 31 minutes, and line ON, that is 165 degree 44 minutes. Now we want to determine the angle between these two lines. Now you are going to see the importance of what I taught you earlier. Okay, now let's proceed. You can see that both line OM and ON comes from an origin known as what? Point 0. Are you getting it? Point O. So let me start this point as point O. Okay, let me write it here. Let me draw my 4 cardinal point here. Let me say this is point O. Okay. So for OM, the bearing is 24 degree and 31 minutes. So, and I know that 24 degree and 31 minutes lies in the first quadrant. Are you getting it? The first quadrant is here. This is the second quadrant, this is the third quadrant, and this is the fourth quadrant. You understand? 24 degree and 31 minutes lies in the first quadrant. So from this point, it will be around this place. So let's say this is 24 degree and 31 minutes. 24 degree and 31 minutes. Do you understand? This line is what? Line OM. So this is M. Please, do you understand? If you didn't understand, you can pause the video and pay attention and listen to the explanation again. We have 4 quadrants in bearing. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Do you understand? The first quadrant is 90 degree, ID, but 24 degree and 31 minutes is not up to 90 degree. Therefore, it will be around the first quadrant. Do you understand? That is how I got this angle. Now let's proceed to construct line ON. Line ON is 165 degree 44 minutes. So from this point to this point, line ON will be in the second quadrant because it is greater than 90 degree. The bearing is greater than 90 degree. So it will be around this side. It will be around this side. It will cover around this side. You understand? It's almost close to 180 degrees. So this is line line ON, okay? This is line ON. Let me call this OM. Do you understand? So now let us proceed. You know, the angle that we want to determine is the angle between the line. You understand? And now to determine the angle between this line. Okay, let me first ask you a question. What is the angle between line OM and line ON? It is this angle that we are dealing with. Do you understand? This is the angle between them. This is line ON and this is line OM. The angle between M and N is what? This angle. You understand? So this is the angle that we want to find. Do you understand? So now let us proceed. Let me call this angle. Let me call this angle theta. Okay? Let's call this angle theta. Now, to determine angle theta, I have to determine this angle. Let me call this small angle X. And let me call this one angle Y. Do you understand? Don't forget that this bearing, the bearing that comes from this north pole to this line is what? 165 degree 44 minutes. I don't know. Let me just write it out, okay? Let me write it out. I don't want to get confused, okay? I draw the arrow. When you are doing yours in your exam, you didn't have to draw the arrow, okay? I drew this arrow so that you can understand. So let's write it 165 degree 44 minutes. Do you understand? This angle is 164 degree 44 minutes. Now let us proceed. I need to determine the value of angle X. Theta is equals to angle X plus angle Y. Do you understand? So in order to determine the value of angle X, don't forget that from this point to this point is what? 90 degree, Abi. So in order to determine the value of angle X, I'm going to subtract 24 degree 31 minutes from 90 degree. Are you getting it? Since I know that, let's have another diagram. Abi, I just want to bring this out, okay? I want to bring this side out. So this is 24 degree 31 minutes. Now, this is angle X, Abi. In order to determine the value of angle X, what do I need to do? I need to subtract 90 degree, I need to subtract 24 degree 31 minutes from 90 degree. So angle X is equal to what? 90 degree minus 24 degree 31 minutes. Now I want you to put your calculator. You are going to get that is 65 degree 21 minutes. 21 minutes. Do you understand how I got that? So angle X is 65 degree 21 minutes. Now let us proceed to calculate the value of angle y, because our theta is the sum of angle here to this point. Are you getting it? This is the value of our theta, the angle that ranges from this point to this point. That is the angle between line OM and line ON. So now, to get the value of y, we have known that the angle from here to this point is what? 165 degree, 44 minutes. I need to get this angle first. Do you understand? Please, I want to pay attention. It's very, very simple, okay? There is no magic to this thing. I need to get this small angle. Let me call this small angle Z. Do you understand? But I know that from this point, the angle from this point to this point is what? 165 degree, 44 minutes. Let me just draw the diagram out. Let's have the diagram. Let's have the diagram, okay? Okay. Now, this is how the angle look like, Abby. And I have theta here. I have angle theta. I have angle theta here. I have known that from this point, this angle that you see here, this angle that you see here is what? 165 degree, 165 degree, 44 minutes, Abby. But I need to, this is the angle that I need. This small angle is the angle that I need. This is angle Y, Abby. I need this small angle. So in order to get this small angle, I need to first calculate this angle, which is small, this angle Z. I need to first calculate it. In order to calculate angle Z, the totality of this angle is what? 180 degree. Just like sum of angles on a straight line. Do you understand? The total angle along this straight line is what? 180 degree. But I know that from this, I know the angle from this point to this point, which is what? 165 degree, 44 minutes. Now, how do I calculate the value of angle Z? Angle Z is equals to, sorry, this is not 2, it is Z, okay? Is equals to 180 degree minus 165 degree, 44 minutes. So, angle Z is equals to, subtract 180 degree, 180 degree from, subtract 165 degree, 44 minutes from 180 degree, that is 14 degree, 16 minutes. Okay, so the value of angle Z is what? 14 degree. The value of this angle is 14 degree, 16 minutes. Do you understand? So now I have gotten the value of this angle. Now I can determine the value of angle Y. Please don't get confused, okay? It is this angle. It is this angle that is equal to what? 165 degree, 44 minutes. But the angle Y ranges from this point to this point. So to get the value of angle Y, I've known that the value of angle Z is what? 14 degree, 60 minutes. So to get the value of this angle Y, I'm going to subtract 90 degree from 14. I'm going to subtract 14 degree, 60 minutes from 90 degree. Because the sum of angle here is what? 90 degree. Do you understand? So, peradventure, if you didn't understand it, you can revise back to your bearing. You understand? So let's proceed. To get the value of angle Y, I'm going to subtract 90 degree minus 14 degree, 16 minutes. Do you understand? So, and if you punch your calculator, you're going to get 75 degree, 44 minutes. 44 minutes. So the value of angle Y is 75 degree, 44 minutes. Please, do you understand what I just did? I don't want you to get confused, okay? The angle between line OM and line ON is what? Angle theta. Is that not it? And angle theta. Okay? Just like you have something like this. This is angle theta. This is the angle between line OM and line ON. But and I represent this angle as X and I represent this angle as Y. So I have to calculate the value of X and Y so that I can sum it together to get the value of theta, which is the angle between line OM and ON. That is what I'm doing, okay? So I've got the value of X as what? Angle X as what? Angle X is 65 degree, 21 minutes. And angle Y is what? 75 degree, 44 minutes. So angle theta is equals to 65 degree, 21 minutes plus 75 degree, 44 minutes. So theta is equals to, if you punch your calculator, that is 145 degree, 5 minutes. Do you understand? So that is the angle between line OM and line ON. Do you understand? So that is how to calculate the angle between two lines. If you didn't understand, you can back this video and watch it again. You understand? So that you can understand how to calculate the angle between two lines. You understand? So now let us proceed to another example. Let's say we are told to calculate the angle between. Let's say we are told to find the angle between this line AB, which is of bearing of 12 degree 51 minutes, and line AC bearing 295 degree 12 minutes. Okay, let's say we want to find the angle between those two lines. Okay, the first step is that we are going to draw our four cardinal points. So let's say we have the 4 cardinal points in this place. You understand? Okay, let's first plot line AB. Line AB is what? Let me call this point A. Okay, line AB, that is the bearing of B from A, is what? 12 degree 51 minutes, and 12 degree 51 minutes lies across the first quadrant because it is not up to 90 degree, or it doesn't pass 90 degree. The first quadrant ranges from 0 to 90 degree. So the 12 degree and 51 minutes lies in the first quadrant, so it will be somewhere here. So let me call this A and let me call this B. You understand? The bearing of B from A is 12 degree 51 minutes. Do you understand? Please, can you see what I wrote here? This is not 120. It is 12 degree and 51 minutes. Okay, we have already plotted this. Let's plot this also. That is the bearing of AC, the bearing of line AC, that is 295 degree 12 minutes. 295 degree is in the third and the fourth quadrant, because it is greater than what? It is greater than 270 degree. Don't forget that from this point to this point is 90. From this point to this point is also 90. 90 plus 90, 180 degree. From this point to this point is what? Also 90. 90 plus 90 plus 90, 270 degree. And this point is what? Third quadrant. Now, the fourth quadrant is this point to this point, which makes it what? 360 degree. But the angle, the bearing here is not up to 360 degree. It is 295 degree, 12 minutes. So it will lie across this point. So I'm going to have my line from this point, drawn from this point. So somewhere like this. Okay. So this is C. Okay. Please, do you understand how I got the diagram? If you didn't understand, you can pause the video and watch it again. Okay. Now let us proceed. So the angle here, let me erase this. Okay. So the angle in this place, the angle that ranges from here, let me just do it here. The angle from this point to this point is what? 295 degree, 12 minutes. Okay. So now I have known the angle here, that is 295 degree, 12 minutes. The angle that I want to find is the angle between this line, which is this. Let me represent it also as what? Theta. Do you understand? The angle between C and B is what? This angle. You can see the angle between the two lines. This is one line, this is another line. The angle between these two lines is what? Theta. You understand? That is the angle that I want to get. Now, I have known that the angle here is what? 12 degree. Abi? Now, but the only angle that I need to find is this angle. Is that not it? Yes, it is. Because I've already known that the angle, this angle is 12 degree, 51 minutes. Now, I need to calculate this angle. If I want to calculate this angle, I know that from this point to this point is what? 295 degree, 12 minutes. Now, in order to calculate this angle, let me represent it as y. In order to calculate angle y, don't forget, from this point Let me redraw this so that you can understand. Okay, let me redraw it. This is how the angle look like, Abi. And I have 12 degree, 51 minutes. And I know that from this point to this point is what? 295 degree, 12 minutes. Now, don't forget that the total angle here, the total angle is what? 360 degree. Is that not it? That is, if you have something like this, the total angle is what? 360 degree. So I know that from this point to this point is what? 295 degree, 12 minutes. So in order to get this small angle, which is angle y, what should I do? I'm going to subtract 295 degree, 12 minutes from what? 360 degree. Please, do you understand? The total angle on our four cardinal point is what? 360 degree. Is that not it? Sum of angle at the point. Let me put it like that. Sum of angle at the point is 360 degree. But I know that from this point, from this northward, the angle that was given from this point to this point is what? 295 degree, 12 minutes. So in order to get this small angle, I'm going to subtract, which is angle y. Angle y is equals to 360 degree minus 295 degree, 12 minutes. And if you punch your calculator, you are going to get angle y. Angle y as 64 degree, 48 minutes. 64 degree, 48 minutes. So the value of angle y is 64 degree, 48 minutes. Now you can see that you have already gotten the value of y as 64 degree, 48 minutes. Please don't get confused at all. This thing is very, very simple. I tell you. We are looking for the angle between two lines. I represent the angle between these two lines as what? Theta. Now, I've already given me that this angle, the angle between these two lines is this angle, and this angle. Is that not it? Yes, it is. But I've already gotten 12 degree, 51 minutes. Immediately I plot this line. It was given as 12 degree, 51 minutes. So I don't need to calculate this angle first. I don't need to calculate this angle again. The only angle that I need to calculate is what? This angle. And I represent it as what? Y. Is that not it? So now, I redo this at this. The sum of angle on the four cardinal point is 360 degree. And I've already been given that from this point to this point is what? 295 degree, 12 minutes. Abi? So I need to get this small angle, which is angle y. What will I do? I'm going to subtract 360 from I'm going to subtract 295 degree, 12 minutes from 360 degree, and that's what I did here. That's why I got 64 degree, 48 minutes. Now you have to get the value of theta. Theta is equals to angle theta is equals to the sum of this angle, which is angle y, and this angle. 64 degree, 48 minutes plus 12 degree, 51 minutes. 12 degree, 51 minutes. So if you punch your calculator, you're going to get 77 degree, 39 minutes. So the angle between these lines is what? 77 degree, 39 minutes. So that is how to determine the angles between two lines. You understand? So let's solve some past question on this course. Okay, you can put this down. A research farm was surveyed and described as follows. At point A to B, the length was 440 kilometers. At point B to C, the length was 250 kilometers. And from C to D, which was parallel to point A to B, the length was 420 kilometers. And from A to D was 202 kilometers. Full stop. Line AB was extended to M, measuring 200 kilometers from point B and joining point C in a quadrant form. The first questioner says, interpret and present the above as a map. Are you getting it? The second question, calculate the perimeter and the area of the farm. The third question, if the entire plot is used for the cultivation of maize, what is the plant population? If the spacing is 60 cm by 60 cm and the sowing rate is what? 2 seeds per hole. The fourth question, if 3/5 of the total farm area is used for cassava production, what is the area left uncultivated? Then the fifth question is, if 5% of the uncultivated area is used for the building of farmstead, what is the proportion of uncultivated land available for production? Now,